मेरे प्यारे दोस्तों, in haloalkanes means halogen derivatives of alkane and arenes, in this which is the topic from 12th, but this concept is for the 11th as well as 12th. So it is very important to study this point because last time also I have uploaded one video in that Markovnikov rule we have discussed. That concept is also for the 11th as well for the 12th. So this concept we are going to start. Which one is that? Anti-Markovnikov rule. जैसे कि देखो, कोई भी अगर एंटीसेप्टिक होता है, मतलब अगर कुछ हुआ है तो मतलब अगर हमें वुंड हुआ है तो उसको क्लियर करने के लिए वो यूज करते हैं, इसलिए उसको बोलते हैं एंटीसेप्टिक. लाइक दैट हियर ऑल्सो द टोटली अपोजिट रूल इज देयर विच इज ऑफ द एंटी-मार्कोनिकोव रूल. दिस इज द अपोजिट रूल ऑफ द मार्कोनिकोव रूल. सो दिस रूल, firstly we are going to start. This rule is firstly introduced by the scientist, that is the Karash and Mayo scientist. Okay, so because of that scientist's name, this rule is also called as Karash rule or Mayo's effect. Okay, keep in mind that Mayo's effect, as well as if we consider this rule is totally opposite to Markovnikov rule, that's why it is also called as a anti-Markovnikov rule. Next one, in this reaction we are using the peroxide, that's why this rule is also called as a peroxide effect. So these are the some points which are the introductory part of this rule. Clear? So in this way we have completed that introductory part. Now we are going to discuss one important point which is very important. As we have discussed in the Markovnikov rule, we can use the unsymmetrical reagent, that is HCl, HBr as well as HI we can use. But for this anti-Markovnikov rule, we cannot use all these three. This rule is applicable only for the HBr. Keep in mind that this anti-Markovnikov rule is applicable for the HBr. Means this rule, HBr addition takes place. What is the reason behind that? That we will discuss now. Okay. Now say if we consider these three unsymmetrical unsymmetrical reagents are there. Out of these three, why only HBr is taking part in this reaction? Now see, if we consider bond length, as we discussed that size, as we know that fluorine, chlorine, bromine, iodine, these are the elements from the same group. Means top to bottom atomic size, top to bottom atomic size increases. If atomic size increases, then the bond length or H and Cl, H and Br, H and I, that bond length also increases. So if we consider that bond length for the HI, HCl, HBr, that also increases. And as a bond length increases, bond dissociation energy. Then what is that bond dissociation energy? That energy required to break the bond. Okay, so that bond dissociation energy decreases. Clear to everyone? So according to that concept, if we consider that HCl, for that one HCl, HBr, HI, first order we are going to discuss for the bond length. Whose bond length will be more highest one? That is of the HI. So it is totally opposite for the bond dissociation energy. Now we are going to write the order for the bond dissociation energy. Now see here, HI, highest bond dissociation energy for the HCl and lowest for the HI. Then now see here, HBr, why we are selecting or why it is applicable for the HBr? This is very important concept. Okay, so this is applicable for the HBr because in case of HCl, bond dissociation energy is high. High bond dissociation energy is required. Okay, bond dissociation required energy is highest one, and because of that it is not possible to break this. It is not possible to break HCl bond. Clear to everyone? This is the reason behind that why HCl is not taking part in this reaction. What is the reason? Reason is that bond length is lowest one, but bond dissociation energy required is higher one, and because of higher bond dissociation energy, that bond breaking is not possible, it is not easy. That's why HCl is not taking part in this reaction. Then what is the reason behind that HI? Hope so you have written all these points, because its notes are very important for you. Now see why HI is not taking part. As we have given reason that HCl having the high bond dissociation energy, that's why. Then what is the reason behind that HI? Before going towards that one, I will tell you this Anti-Markovnikov rule is followed not by the electrophilic reaction, it is followed by the free radical reaction. Okay, this is the free radical reaction. This is very important. So in case of HI, when there is a radical formation will takes place, at that time H radical I radical formation will takes place, but at that time iodine is always preferred to combine with the another one iodine radical to form a I2 molecule. That's why HBr is only favorable for this reaction. Clear to everyone? So I have given reasons behind that also. So keep in mind that reason for the HCl is bond dissociation energy required is very high, and that's why bond breaking between that H and Cl is not easy or difficult, required more energy. Clear? In case of HI, free radical reaction, so H radical I radical formation will take place. I radical preferred to form the I2 molecule instead of combining with the another radical. Clear? So next one point we are going to discuss, that is the statement of this reaction. Before going towards that statement, I will revise you that Markovnikov rule and Anti-Markovnikov rule by using one example. For that one, we are taking one example, that is the CH3 CH double bond CH2. This is the structure of propene. In that, if we consider Markovnikov rule, here we are going to discuss Markovnikov rule, means only HBr. Here HBr plus peroxide is there. Clear to everyone? So by using this concept, we can write the statement also. Now see, what is the Markovnikov rule? Negative part of the reagent get attached to that carbon from the alkene which having the less number of hydrogen. Means that Br minus will attach to this carbon. So we will get the product, that is the CH3 CHBr CH3, means we are getting here 2 bromopropane. Clear to everyone? But if we consider that next question, in that what is the statement? We have not discussed the statement, but we are getting the opposite product, means instead of this carbon, that Br minus will get attached to that carbon. So what is the statement? Keep in mind that we will write it here also, but keep in mind that negative part of the unsymmetrical reagent get attached to that carbon of the alkene or containing carbon-carbon double bond which having the more number of hydrogen. That reaction takes place in presence of peroxide. So what will be the product? CH3 CH2 CH2Br. What is the name? 1-bromopropane. So see, it is totally opposite to Markovnikov rule. Here it is attached to less hydrogen containing carbon, while it is attached to more hydrogen containing carbon. Keep in mind that this is a question most of the time we ask in exam also. One arrow there will be the only HBr, one arrow will be HBr along with the peroxide. Okay, so now we are going to write the definition, or not definition, we are going to write the statement. So what is the statement? See here, this is the free radical reaction. Okay, statement is that, what is the statement? When unsymmetrical reagent is get added, when unsymmetrical reagent is get added to the unsymmetrical alkene, then alkene in presence of peroxide, peroxide. This is very important. Okay, so when unsymmetrical reagent is get added to the unsymmetrical alkene in presence of peroxide, then negative part of the reagent get attached to that carbon having more number of hydrogen atoms. So this is the statement. Hope so you have completed its write up also. What is the statement? See, listen carefully. When unsymmetrical reagent, for example here we are using only HBr, get added to unsymmetrical alkene, as we have discussed 1-propene, okay, in presence of peroxide. Now which type of peroxide can be used? So peroxide we can use, that is the sometimes only peroxide word will be written, otherwise they will give us sodium peroxide, means N2O2, or benzoyl peroxide. What is that? Benzoyl peroxide. What is the structure of benzoyl peroxide? That structure is benzene ring, okay, C double bond O, peroxide, so double single means oxygen single bond, again this part is repeated here. So this is the structure of benzoyl peroxide. Clear to everyone? So now in this way we have completed this reaction. Now we are going to discuss the mechanism of this reaction, because it is very important to know the mechanism also. If you have completed its write-up, it's very good. Complete this structure also. 1-propane CH3 CH double bond CH2 in presence of benzoyl peroxide. Okay, so benzoyl peroxide, it gives 1-bromopropane CH3 CH2 CH2 Br. Now we are going to discuss the mechanism. Before going towards the directly reaction, we should know the steps of this one. So firstly, that benzoyl peroxide, it forms the radical. So this is the structure of benzoyl peroxide. If we consider that middle part, it is symmetrical. Okay, so because of that, if we are dividing from this side, then what will happen? See here, this bond, one bond, 2 electrons are required, like that. 1 electron we are giving to this oxygen, 1 electron to this oxygen. Then what will happen? That benzene ring, now see, because of partition, what will happen? This and this means both are the similar ones. So we are getting here 2 moles of benzene attached to C double bond O radical. 2 moles of this one we are getting here. Next step is that here there is a removal of CO2 will takes place. How that removal of CO2 will takes place? Now see here, CO2. For this one, here this bond breaking takes place, means for this one, 1 electron is entering here and another 1 electron is there. So in this way, 1 plus 1, 2 electrons are there, means 1 bond formation is possible. But here along with that bond formation, this bond breaking is takes place, means here we are removing CO2, but along with that there is a formation of 2 moles of benzoyl radical. So that also can be written like that, C6H5 dot. Clear to everyone? This only I have written in this format. Now what is the next step? Next step is that C6H5 radical. That one radical we have taken here. It combining with the HBr. At that time, 1 electron is given to Br, 1 electron to the H, and that electron is used to form the bond with this one. So in this way, here bond formation will take place in between that hydrogen and this benzene radical. So here we are getting this benzene, okay, here hydrogen is attached. It is nothing but C6H5, already it was there, and 1 hydrogen is attached, means that number of hydrogen is becoming 6. Clear to everyone? Now see, because of bond breaking, what is happening here? Br radical formation takes place. So here Br radical is formed. Clear to everyone? Now this Br radical which is formed in this step, that is reacting with that alkene, propene. So CH3, CH, double bond, CH2. Here also that bond breaking and free radical formation will takes place. Okay, so which radical will form? CH3, CH radical, single bond, CH2 radical. Clear to everyone? Now what will happen if we consider here that one, which one Br radical is formed in that previous step, that will react here. But that Br radical having the two options. One, to combine with this radical, and second option to combine with this radical. So in that, if we consider this one, okay, so in this way what will happen here? CH3, first step, if we are combining this Br radical with this one, then what will be the product? CHBr. Okay, then what will happen? CH2 radical will remain as it is. Okay, now next one, if that Br radical is combining here, then what will happen? CH3, CH radical, CH2 Br. Okay, now see, whatever radical form in this reaction here, that radical containing carbon, it is attached to only one carbon, means this is the primary radical and this is the secondary radical. As we know that stability order for the free radicals, in that tertiary free radical is more stable than the secondary than the primary. So if we are following this order, which is the stability order for the free radicals, according to that if we consider, then this one will be the more stable. So what will happen? Next HBr will combine here. Then what will happen? Out of this Br, means HBr, H radical as well as Br radical will be there. So we will think that yes, I think so Br also will get attached, but no. Why Br radical is not attaching here? Because already Br is there. If that Br is also entering here, then steric hindrance will be there. Because of steric hindrance, that Br radical will not combine with this radical. Only H plus means H radical will combine here. So here that bond formation will takes place, and we are getting the final product, that is the CH3, CH2, CH2Br. Clear to everyone? So this is the final product, that is the 1-bromopropane. In this way, I have tried to explain you Markovnikov rule as well as anti-Markovnikov rule with the help of this mechanism also. If you are understanding this concept, it is very good. Otherwise, if you have any doubt, you can write in a comment box also. Thank you all of you.